Hi everyone, I'm Rongji. Now let's move on to part 2. I will show you a live demo on how to generate and analyze a Wi-Fi 8 UHR MU PPDU signal. Let's get started. For this demo, I'm using M9415A VXT transceiver here with the signal generator directly connected to the analyzer. Now let's hop into Signal Studio to generate our signal. Signal Studio now has quick setup buttons for A-NOR 2.11bn and works with multiple hardware platforms. Here, let's select the M9415A VXT transceiver to open this waveform setup page. To connect the instrument, go to the System menu, click on Change Hardware Connections. Then, click New to enter the IP address or select a stored device. For this demo, I will use the instrument type stored before. Once connected, you will see a notification in the status bar, and you can check the hardware details on the hardware page. Now let's go to the instrument subpage to configure the center frequency and amplitude. Next, we've moved to the waveform setup page. Under generation mode, you will see that 3 UHR PPDU formats are supported. In our case, select MU PPDU option. For bandwidth, let's choose 20 MHz. Now, let's head over to the signal configuration page to configure each individual field. In the General Settings menu, set the UHR LTF symbol interval to 4 times UHR LTF plus 3.2 microseconds, and the number of transmit trains to 1. Under the U6 settings, set the link mode to downlink and the BSS color to 5. Signal Studio has a built-in hint feature that helps configure settings correctly based on IEEE standards. To support OFDMA, let's disable compression mode here. Under RU allocation index, you will see 3 resource units for 20 MHz, each assigned to one user and for one spatial stream use. Now, let's configure the users. Let's go to the RU1 page. Here you can adjust the power boost factor and spatial matrix. Let's select user 0. Now you can configure settings like the station ID will enable longer block codes for LDPC and set the modulation and coding schemes to 90. For the MPDU MAC header, I will keep the default settings. Next, let's turn on long block codes for user 2 and user 3. We'll change user 2's modulation schemes to 20 and user 3's modulation schemes to 23. Once everything is set, click Generate Waveform, then download to send it to the instrument. You will see a Download Succeed message. We are ready to analyze the signal. Now let's switch to X-apps to demodulate and analyze our signal. First, select WLAN and choose Modulation Analysis Measurement Application. In the WLAN mode, make sure to set correct trigger mode and center frequency. Now, in the radio standard menu, you will see A-NOR 2.11bn is supported. Select 11bn 20 MHz and press OK. You will see the signal is now successfully demodulated. To view more measurement results, go to the Display menu, select the View tab, and choose User View. Here, you will see constellation diagrams, IQ EVM results table, user information summary, and the decoded UHR SIG user views. Let's double-click on the user information summary to maximize the results window. Here, you will find the detected RU size, EVM, power, and the modulation schemes values for each user. To access PSDU decoding information, go to the Mass Setup menu, select the Demo tab, and enable Date Decode. Now you can see the PSDU length and the CRC details for each user. Next, let's compare this with Signal Studio to verify the demodulation results. For the user 1, MCS 19, station ID 334, LDPC is enabled, PSDU length 1008 miles. For the user 2, MCS 20, station ID 386, LDPC is enabled, PSDU length 295 bytes. For the user 3, MCS 23 station ID 486, double LDPC is enabled, PSDU length 2018 bytes. Now let's double-click on the UHR SIG user field to maximize the results window. Let's change the results window view to burst info. Now you can see the demodulation results for each date field. The system has correctly detected the signal as 11BN 20 MHz with the PPDU format set to MU PPDU. You can also check UHR SIG common field for the guard interval size, special reuse, package extension, and other key parameters. Finally, in Signal Info table, you will find decoded USIG data like TXOP duration, BSS color, bandwidth, and uplink/downlink settings here. And that's it. X-apps fully supports Wi-Fi 8 UHR MU PPDU demodulation, including the detailed analysis table for each date field and user information. This makes Wi-Fi 8 testing faster and more efficient. To learn more and to download a free trial, visit us at this website. Thank you for watching.